just to introduce myself, so my name is Karan. I am a program manager in the Azure Compute team, and primarily I work on the HPC space. So our team is a team that essentially provides accelerated offerings like GPUs, FPGAs in the future, and then obviously things such as Azure Batch as a platform service. So today we're going to be covering most of the GPU side of it. I'll talk a little bit about some of the things that I'll talk about are sort of the state of the union in regards to things like where does kind of the offering itself stand. I'm going to do a technology recap for those of you who don't know a lot about the offering today. I'm going to talk a little bit about some of the targeted markets for GPUs, especially sort of AI and deep learning, the traditional sort of compute stack. And I'll talk about visualization as well. And then most of the rest of the time, I will definitely want to try and spend as much as possible on customers and partners that we've onboarded and some of the work that they've been doing on top of these VMs. And that's kind of what we'll do, and we'll try and sort of fit in some demos in the middle if we can as well. So just to start off from a perspective of what is our team mission from an HPC perspective. We really are trying to get to that stage where we achieve true HPC in the cloud. What that means is a no compromise on infrastructure. So if you are porting from your bare metal infrastructure into the cloud, you should ideally not see any performance dip. So we're trying to get to as close bare metal as performance as possible. Additionally, our strategy is always going to be in scale out. What that means is we are going to be working on our networking. So things such as InfiniBand is definitely part of the equation there. And we're going to be working a lot with partners like NVIDIA and Mellanox and a few others that I haven't pointed out here. So, and in this case, for example, NVIDIA is not even a partner. They're more aligned as a development partner, where some of the code that we've been developing on drivers are actually making it into the mainline drivers that NVIDIA actually releases. So there's actually a much more cohesive partnership there. So, state of the union, basically, where does the GPU series on Azure stand today? Most of the customers that we had, during preview are continuing in public availability. We GA'd the service on 1st of December. We've had huge amounts of interest in the offering. We've essentially been sold out since day one, since we've had this offering live, and so we're building up and we're ramping to satisfy that demand as much as possible. So we just can't build enough of these things quickly. Additionally, GPU is definitely at the forefront of the hardware innovation, and I'll talk a little bit about why that is. It's primarily due to some of the work we've done under the covers in the infrastructure layer to achieve that performance. And then there's a lot of first-party products built on N-Series, such as actually recently, 2 days ago, there was an announcement of a new service from Microsoft Cognitive Services called Chris.ai. It's essentially a speech-to-text caption-based service. It's built entirely upon N-Series and Azure Batch. So Azure Batch to actually schedule the VMs, and then actually the GPU VMs to do things like deep learning for the speech recognition. And then we've obviously got hundreds and hundreds of external customers already in production in less than 3 months, which is pretty incredible as well. Where do we have these VMs available today? So right now we have these VMs available in essentially in there we go. So we have these VMs available in a few regions today. The offering is obviously divided into two different offerings, compute and visualization, which is why you're seeing the two different letters there. So V stands for visualization, C stands for compute. We've got it in East US, a North Central, South Central, and then we've expanded to Amsterdam, so that's West Europe, and then also additionally Singapore, so that's Southeast Asia. We will be expanding in the next 3 months to various other data centers, including West US, also additionally government cloud. We'll also be expanding to regions such as Dublin, which is North Europe, and then we'll also be expanding to Japan as well. So there's lots of more capacity to come out and much more regions that will be supported in the next 3 months. Let me do a quick technology recap. Where do we stand with the offering, what the offering actually is, and how does it actually work? So right now we have 2 sets of offerings. This is the compute virtual machines. So this is NC-based instances, and the primary backend of this instance is a NVIDIA Tesla K80 card. Now, a K80 card is a dual GPU design. So what that means is the picture that you see on the right-hand side, that full card actually has 2 GPUs stacked on top of it. But what happens is that those 2 GPUs pop up as 2 separate devices. So that's why when I say one K80 GPU, we actually mean half a physical card. So you're able to get essentially 1, 2, or 4, and then additionally the cores are physical cores. They're not hyper-threaded cores. So you can think of this as 6 cores to 1 GPU. And additionally, at the end, we have also an additional VM size at the end, and the only difference there is InfiniBand. So essentially, this is our partnership with Mellanox, and so there's a second and backend network, which essentially allows you to talk to a single VM to another VM with very, very low latency. We're talking about less than 2 microseconds of latency between a single VM to another VM, another full VM. This is essentially as good as bare metal. So that's really going to help with things like MPI or AI workloads. So the next one here is NV, which is the visualization virtual machines, and these are backed by NVIDIA's Tesla M60. This is essentially another card, but essentially the same VM size. So essentially we'll have essentially again 1, 2, or 4 GPUs in a single VM, and again this is a dual GPU design, so you'll be able to get half a card, 1 card, or 2 full physical cards. Now think of these VMs as essentially being remote desktop VMs or workstation VMs where you're able to run high-end 3D applications and things of the nature. Now I've got an additional row down the bottom here which talks about Grid and Quadro. Now what Quadro means is Quadro is a professional graphics software stack from NVIDIA that today requires customers to go buy a license per user, which could be thousands of dollars, and then essentially spin up a license server and connect it to their machine. In the case of Azure, we don't have to do any of that. What that means is you just launch the VM, you install the driver, and all just works. There's no license service to pick up. There's no additional cost. The licensing cost is embedded in the compute cost of the VM. So here I mentioned that there's a single license per GPU, and then you can get up to 4 licenses per for the full VM. So essentially what this means is you can run a full workstation license, meaning single user concurrently on a single VM if you're doing desktop-based scenarios. Why is graphics important? It is really important, as most of the applications out there today are being accelerated with GPUs and actually integrated graphics as well. So a lot of enterprise customers are using these applications out of the box today, and VDI is growing day by day as well. So you can think of NVIDIA Grid as essentially being that piece. Now, one thing to note here is that all of these applications are actually applications that are certified officially by the ISV and NVIDIA to run on Quadro-based cards. What that means is for customers, they can just basically lift and shift these apps onto these VMs, and they don't have to recertify them at all. They can just run them, and they'll just work. So you can think of that, the Azure platform, obviously, and then the M60 GPUs And then the driver that we provide today will have the Quadro capabilities. So when you install the driver, those capabilities will be live. So you can use you can use basically the AutoCAD suite, the Autodesk suite, the Adobe shops, and then additionally there's a list of applications that are supported on Quadro that you can check out as well. Talk a little bit about architecture. This is essentially how Azure works today, so I wanted to dig into that a little bit. So obviously at the most bottom end here, we essentially have the hardware itself, right? So this is our data centers. Data centers have clusters. Clusters have racks, and racks have servers in them. And these servers can either be an M60 server or a K80 server. On top of that, today we have our host OS. Now, all of Azure today actually runs Server 2012 R2 as our host OS. And then, in the case of GPUs, in fact, we are running Server 2016 as our host OS. And the reason for that is how we provision GPUs, which is through Hyper-V, which is our hypervisor, and then through a feature called DDA, which I'll talk about a little bit later. So, and then on top of that, you can run your client OS, whether it's Windows or Linux, and then on top of that, we have your applications. So you can bring your own images, you can run some applications for the marketplace, you can build your own custom apps and services, and additionally, you can use platform Azure services like Azure Batch to schedule GPU VMs as well. So this is kind of the flow that happens in Azure today. Now, one thing to note is you can actually run this entire architecture on-premise if you like. Server 16 ships with these features, the ones that we actually use to provision GPUs. So you could literally bring up a server and run hypervisor on it with DDA and expose a GPU, and you essentially have a mini Azure based infrastructure running as well. We've also additionally worked with remote desktop services team to improve graphics and add support for OpenGL and OpenCL. These were previously not supported, not as well supported, and additionally, there's a lot of work being done to enhance the quality and the protocol itself to work with the GPU VM. So you'll see a slightly different, much more performant remote desktop protocol on the GPUs. DDA, so this is essentially the technology that we use to launch or provision GPUs into a VM. What it stands for is Discrete Device Assignment. It's actually a feature that shipped as part of Hyper-V inside Server 2016. And essentially what it allows us to do is it allows us to essentially map an entire device, a physical device, to a VM. So there's no virtualization of the device happening at all. We don't virtualize the device at all, which is how we're getting up to 95% bare metal performance on a single VM, which is pretty incredible. So you're getting almost bare metal performance on a VM, and you're able to get an entire device directly. And if you're obviously running this on-prem, you can use a PowerShell command to do the mapping directly on the host. And so what essentially it looks like is this. When you open up a device manager, you'll just see a physical device attached to your display, which is in this case either a K80 or an M60 GPU. And then again, if you pick the different multiple GPUs, you'll be able to get 1, 2, or 4 GPUs in there as well. So talk a little bit about state of affairs as to where we are today with things like supportability. All of the drivers are available through MS-DOCs today. They will be provided by NVIDIA as well. So for a K80, you can actually go to the NVIDIA website and download the driver, or obviously you can come to the MS-DOCs as well. But if you wanted the latest driver, you can always go to the NVIDIA website and get it. Now, in the case of a M60, because it's a licensed driver, you have to get it from MS today, the Microsoft Docs website today. But shortly, what's going to actually happen is that NVIDIA will be publishing an image where the driver is pre-baked for an M60, because an M60 driver requires a reboot of the VM before it's ready to use. So actually, NVIDIA will be providing an image with a pre-baked driver inside Windows. So there'll be 2 images coming out for that. Linux support for M60 is also coming late February for CentOS, Red Hat, Enterprise Linux, and Ubuntu. This was previously not supported, but there is support coming in the latest driver release from NVIDIA, so you'll be able to use Linux on desktop for visualization scenarios as well. And Linux support for K80 is actually being expanded to CentOS, Ubuntu, and Red Hat Enterprise Linux. So initially it was only Ubuntu 16.04, but we've now added CentOS and Red Hat 7.3 to that as well. And additionally, if you wanted to use Linux on the NT24R, which has the InfiniBand, there's a driver that is coming soon, and we'll be publishing that hopefully before the end of the month as well. So most of the scenarios will be covered on these GPUs. So I do want to switch gear a little bit and talk about some of the things that we are doing on these GPUs, especially in terms of artificial intelligence and deep learning. There's been a lot of talk about artificial intelligence lately, and it's part of the work that we've been doing, obviously on the current GPUs, but also upcoming GPUs as well. So just to give you guys a few examples as well, AI is definitely everywhere, right? So you kind of interact with all of it today. So for example, Netflix is actually building recommendation engines on the GPUs to actually train to look at people's viewing history to figure out what they would like to see next. Additionally, things like such as Cortana or Siri or Google Now are actually using millions of hours of content to train itself to figure out, what the customer is actually talking to them about, so that it can actually go and do the speech recognition efficiently as well. It is definitely touching a lot of people's lives. So actually on the far right, you can see a person that's blind. This is actually a project within Microsoft called Project Blind. And additionally, essentially, this person actually works for Microsoft, and he's blind. And so what's happening here is he's got these glasses that have a camera that are taking photos of what's in front of him. And then those photos are then being uploaded into the cloud, into Azure storage. And then cognitive services are running an algorithm on top of those images to figure out what's actually in those. And then once those images have been recognized, then that content is then being converted into speech, into audio essentially, and then being fed through his phone directly to a speaker in his ear. So it actually completely changes the way he lives his life, right? So he can look at a menu now, and he can read a menu. He can actually see if a person is smiling or frowning or crying or laughing, essentially. The one in the middle is actually a pretty interesting one. This is a children's hospital in Los Angeles, which is actually using 20 years of health data to train a model on a GPU to figure out, what are the characteristics of, or what is the metadata of a certain disease, and to figure out if there's any preventive care that can be provided. On the far left, there's obviously Skype translator, which is actually on a GPU. So this is actually dynamic speech generation that's happening on a GPU as well. And it's fueling all industries. These are live projects out in the world today. So on the far right is a project called Lettuce Project, and what you see there is actually these little cameras are in front of it, and what it's doing is it's capturing an image in front of it, and it's actually figuring out if the image has a lettuce or a weed. And if it's a weed, it just sprays enough herbicide to kill the weed and not the lettuce. So this has actually improved productivity by 95% in the agriculture space just by using AI on GPU. The one in the middle is a project called Connie, Project Connie, which is a hotel concierge. In fact, there's actually a replica of this in Building 99 Microsoft, where you can actually go and talk to this robot as well. So essentially what this project does is you can go up to it and ask it natural language questions so it can recognize what you're saying. So you can actually come in and say, hey, give me the best sushi restaurant and make me a booking there. And in the case of Microsoft, you can actually go up there and actually ask and say, hey, Connie, tell me where my next meeting is, and it's actually going to point you in the right direction of your meeting by looking up your calendar. And then on the far left-hand side over here, there's a airport project where essentially if you've lost your child, you can actually go to the security center, and they will essentially run GPU-based they will run GPU-based tagging on the video frames to figure out where your child was last seen. So we'll actually do face recognition on the video by running it on a GPU as well. So all this stuff is great, but what the heck is deep learning? How do we define it? And that's a lot of question. That's most of the time. Most people are like, "What is deep learning? How does that actually work?" I mean, a lot of people understand kind of the use cases that come out of it, which I just explained. But underneath the covers, what is deep learning? So the way these things work is essentially there's two parts to it. There's a training part, which is you actually are training the computer to learn a certain thing. For example, this is a cat, this is a dog, this is a pen. You're actually training the computer to recognize these things, and you would do this millions and millions and millions of times, which is why it's so computationally intensive, and which is why GPUs can turn these things from years to days to hours, essentially. And then on the right-hand side, once the model is being trained, you infer upon it. You actually ask it interesting questions. You ask it things like, okay, tell me if this is a cat. Tell me if this is a dog. And then the model will actually then, with a certain accuracy, be able to tell you what it is. And so all of this obviously demands a lot of compute power. This is a virtuous cycle. It keeps happening, right? Data only grows, so you keep adding to the data and you keep training. And so the rate of improvement ever since GPUs arrived on the scene has been crazy. You can actually see from some of this stuff in the middle. For example, pedestrian detection. So this is actually live. This is actually live technology being put into cars. This is the future of autonomous vehicles, for example, in Tesla and some of the other manufacturers, where they're actually deploying pedestrian detection-based inferencing systems in the cars, so they can actually detect if there's an object, if there's a pedestrian, and actually recognize that data. Now you can see that the actual accuracy of those recognitions have improved astronomically in a very short amount of time when the GPUs arrived, and which is why GPUs are very, very relevant in this space. Now, every deep learning framework out there is GPU accelerated. So there's a lot of them out there. Most of them are open source. Obviously, Microsoft's got its own, which is CNTK, which is now called Cognitive Toolkit, and then Google's got their own called TensorFlow, and then there's another one called MXNet as well, which comes out of locally over here as well. So there's lots of different types of frameworks out there as well. So, with the help of CNTK from Microsoft, we were able to achieve pretty awesome things. Now, last year at Supercomputing, Jensen, the CEO of NVIDIA, actually announced that Cognitive Toolkit is now the fastest toolkit on the planet to run any kind of training on Azure or any of their GPUs, which is a pretty big deal. So, Cognitive Toolkit is open source. You can use it today, so I'd encourage you to go check it out as well. And it's all GPU accelerated. Additionally, using Cognitive Toolkit, the CNTK team inside AI research in Microsoft was able to have pretty historic, achievements. This was actually a couple of months ago, where now the training that happens on a GPU for speech recognition is now on par with a human, human actually doing that speech transcription as well. So this is pretty incredible just at this stage, but it's only going to get better as well with more data. So this is pretty incredible. I talked about Seeing AI project, which is pretty cool. Another project, Skype Translator, and then the other project that internally MSR is working with is the smart refrigerator. So this is essentially making your devices much more cognizant or context aware. So imagine going to the supermarket and thinking, hey, what do I have in my fridge? You can now talk to Cortana and say, Cortana, tell me how many eggs I have in my fridge, and we will actually do the recognition using cognitive services on GPU to figure out what you actually have by taking essentially on the left-hand side, you can see there's a photo, and then based on the accuracy, it will actually tell you, I'm 95% sure that this is a camera. I'm 97% sure that this is a orange juice. So you can think of some of the more interesting things that can come out of this here. And then additionally, we talked, last year we announced a pretty interesting partnership with OpenAI. For those of you who don't know, OpenAI is a nonprofit research organization that was that was essentially founded by Elon Musk from Tesla, and in the photo that you see is Sam Altman, who is the chairman of Y Combinator. So, we've been working alongside them. The HPC team, including ourselves, have been working alongside them to essentially, push the boundaries of what AI can do, and especially on GPUs in Azure. And so, there's going to be more news coming out in the future about the tools and things that they build on Azure GPUs. So look out for that. So let me do a quick demo of what this stuff actually means and how you can use it. And again, just what I'm going to be showing off is all open source. You can go ahead and download this stuff on GitHub. So it's pretty cool. So here, what we have is, let me know when you can see this. If this is too small, please let me know. We can try and zoom this stuff in. But so here on the left-hand side, what we have is a CPU VM. So this is essentially got 4 physical cores, CPU cores, and then on the right-hand side, we are remoted into a GPU VM. So on the right-hand side, you can actually see there's 4 GPUs right here. Now, what I'm going to do is I'm going to run a training job, and I'm going to start the job now, and then I'm going to explain to you what's actually happening. So I'm actually calling a command line called CPU run, calling a script here. So I'm going to enter that, and then I'm going to move over to the right-hand side, and I'm going to run it on the GPU. Now, let me exactly explain what's happening. So what I'm training is I'm training a model with 60,000 images to recognize hand-digit expressions. So basically, 60,000 images of handwritten numbers, and it's actually going to train a model to recognize what a digit is going to be. And on the left-hand side, the training is running on a CPU. On the right-hand side, the training is starting to run on a GPU. On the right bottom side, you can see a tool called NVSMI. Now, this tool is actually a tool that we ship with the current VM. So when you launch the VM, this tool is already pre-installed by NVIDIA. And you can actually see the metadata about the job. So, for example, you can see things like, what the temperature of the GPU itself is. So we've got 4 Tesla K80s here. So this is an NC24. You can see that there's now actually, there we go. So utilization now is happening. So you can see these GPUs are going up in utilization, 65%, 66%, 72%, and it's actually churning through all of that 60,000 images to train the model. On the left-hand side, you can see the 4 cores are at 100%, and if you see in the log lines, you can say starting epoch 2, which is okay, but on the right-hand side, we can see that this is already on epoch 9. Now, rest assured, the GPU side is going to go blast through this training and actually be finished in a fraction of time compared to the one on the left, which is pretty cool. So I'm going to leave this running. Obviously, you can believe me when I say that this is going to run in a fraction of time. You can already see on the right-hand side, this is on epoch 13. The one on the left is on epoch 3. So these are essentially mini batches sizes of the images that are being trained. So what I'm going to do is, okay, so let's just assume that I've trained my model now, right? I've got a model that can recognize handwritten digit expressions. What do I do with that? How do I infer upon it? So what I'm going to do is I'm going to launch a application called Paint. And what I'm going to do here is I'm actually going to draw a number on here. So I'm going to draw a number, let's say 5. Let's see if this works. I'm going to save that. And then I'm going to go command line here. I've written a little command line executable that actually evaluates this image and figures out what's on it by using the model that we just trained. So I'm gonna do that. Oh, so that says 3. So obviously I didn't write it good enough. Let me write it again. Let's do that. Let's see what that says. There we go. So it's actually gone ahead and said 5 now. So this was obviously no smoke and mirrors because I obviously did not draw the 5 correctly the first time, which I have now in this case. And so now it recognizes this as the classification result is 5. So this is a pretty, pretty simple example, but it kind of shows you the power of what's possible by training stuff and then recognizing it at the other side. So you can then extrapolate this out to all the things that I talked about in terms of, doing things like, cancer research and medical or architecture or agricultural or image recognition. So lots of stuff that can be done on this. Now this project is called Azure Batch Shipyard. It's actually a GitHub open sourced, and all of this code is already written for you. You just have to run it, and you can actually go in and change things around. So Azure Batch actually launches the VM. It actually spins up a Docker image of CNTK and then runs this algorithm on it as well. So we already have pre-built recipes that you can go download and play around with. So let's just talk about some real-world use cases. Some of the customers that we've actually been working with, and some of the real-world use cases. Now I know this is a Skype session, so this might be a little bit laggy, but you know what you're seeing here right now is actually 90 streams of video running concurrently on a single GPU, being streamed from the M60 GPU directly into the K80 GPU to do image recognition. So every single frame of every single video is being fed through the single K80 GPU to recognize what's going on in it. So here, for example, in the middle, you can see this says juggling balls. On the right-hand side, it says jumping jack. On the one right hand to that says jumping rope. So a single GPU is actually going through 90 concurrent streams and figuring out what's happening in each one. Now, there we go. So this is a second one. This is actually a pretty fun one. So this is a video so this is actually a model that's been trained to recognize what Picasso, how Picasso draws. And then on the other side, what we're doing is we're feeding the model a video to actually change it and actually figure out what Picasso would have done in today's world. So this is actually feeding a real-time video from an M60 into a K80 to then change it into what Picasso would have done. So this is actually going through different filters and actually figuring out, how Picasso actually draws and how he would change today's world. So this is actually a pretty interesting example as well. Here's another one. So this one, in fact, is being used by a lot of different weather simulation experts and companies. So this is actually a terabyte of data being fed through a single GPU to figure out what makes a tornado dangerous. What are the features or characteristics of a tornado that make it dangerous? And then they can use that data to then actually do good enough prediction. And additionally, they can actually then use that to do things like predictive emergency response. So here's a real customer that is actually on N-Series today. City of Hope is one of the top-rated cancer research facilities out there, and they're using the N-Series to actually do things like studying the dynamics of proteins. They're actually doing a lot of cancer research on N-Series. Algorithmia is another startup that is an open marketplace for algorithms, and so this is essentially, think of this as the inferencing side. So they actually internally build all these algorithms for things like computer vision, machine learning, sentiment analysis, recommendation engines. Once they build those models, they then provide them as APIs on their web page to then be consumed as an inferencing service. Audioburst is another one, which is essentially, going through terabytes of data of content to then figure out what the people are talking about. So you can write an image, you can write a text piece. So you can say things like, you can essentially say things like Super Bowl, and it will actually figure out, what the world has been talking about and give you those exact clips. So all of this is happening dynamically on a single GPU as well. Noonim is a startup in the financial analysis space, and so what they're actually doing is quite interesting. They're taking data from places such as Reuters and Bloomberg, some of the data that is very expensive, and then running machine learning algorithms on top of it, and then providing that as a service to second and third tier banks that actually can't afford the original data. So this is actually turning the financial analysis into a completely different type of service. And sort of democratizing it to lower tiered banks and financial institutions, which is actually pretty cool. And all of that work, again, is all done on N-Series. This one's pretty interesting. MapD, they're actually looking to, they're actually testing on Azure today. And it's a GPU accelerated database that you can actually run on Azure. And you can do things like interesting analytics, where you can in real time search for hashtags or tweets and actually figure out where in the geolocation those are happening. And you can actually dig directly into the maps and figure that out. So which is pretty interesting. Jellyfish Pitches is actually one that Satya on stage has talked about before. This is a small Emmy and BAFTA award-winning studio that actually did some of the Star Wars work recently as well. They are actually a complete Azure chop shop. So they use both M60 and the K80s in the cloud. Additionally, they use other services in Azure as well. But essentially, they use the M60 to do employee retention, which is pretty interesting. So Jellyfish Pitches in UK has, is the home, but they have artists all around the world. And today, they have to buy a $10,000 artist rig and ship it out to them. But with the introduction of M60, we're able to just give them a private IP or a VPN login and essentially able to give them a high-end workstation directly in Azure. So the cool thing here then is all the content is created directly in the cloud, and then they then use the same data to then produce the final content using a K80 by using things like V-Ray that renders on GPU, or by using things like Octane, that's a GPU-based ray tracing renderer as well. Oceaneering is actually another company that is doing something similar, but is in the oil and gas space. So this is Oceaneering again is all Azure. They're multi-billion-dollar subsea surfacing company that builds these submarines. These little submarines, and what they do is these submarines actually go underwater, and they actually do things like maintenance, decommissioning, repairs, things like that. And they have to build these models in 3D space to figure out how they're going to tackle this challenge. So I've got a little video here that actually showcases a job that they ran, it showcases kind of the capability that they can use on Azure, where they're using 3,600 cores to render essentially 1,000 frames in under an hour, and those 1,000 frames could have taken 300 hours on a single VM. But they were able to schedule that on Azure and get it done much, much quicker. Now, the cool thing here is they're actually producing this content in Azure itself. So they're actually running an instance of 3ds Max on an M60. Now, let me see if I can bring that up and showcase that to you as well. Please bear with me. Okay, so let's see if that pops up. There we go. Okay, so here what we have essentially, so this is a 3ds Max full high-end 3D application running in the cloud in Azure today. This was never possible before until M60s came to the fray. So this is Autodesk's professional application running in the cloud, and this is a 3D model in 3D space where I can actually manipulate within it and actually figure out how I'm going to run this data. So this is actually content being created directly in the cloud by Oceaneering, so they can actually figure out how they're going to be able to render this. Now, from within here, they actually submit a job to Azure Bash to then do the large-scale rendering as well. Now, once those jobs are completed, they create these outputs here. So, for example, here we've got a bunch of PNG files that are essentially frames of all the outputs. Now, if I double-click one of them, what it's going to open up is a little thing here that's going to showcase to me what actually the end result potentially looks like. So this is an oil rig, and here's the little subsurface submarine, and that's actually is going to go and do a bunch of maintenance work on this rig here. So this is actually sort of the power that they're using in the cloud, which is pretty exciting. And actually, if I open up a device manager here, now you can see there's 2 Tesla M60 cards here. So this is a live VM 2,000 miles away in San Antonio data center, and I'm using it here in Seattle with no problems. So this is actually a full high-end workstation desktop running Quadro-based capability from NVIDIA in Azure. So let me get out of that. Here's another customer, IKEA. They're actually building a lot of their their models. So all of the content that they build is mostly all digital, and they're using things like Octane and V-Ray to actually render their stuff. Now, the interesting thing here is that the image that you see on the right over here is actually not real. It's actually a digital recreation of the real world, and they're actually using things like V-Ray to recreate it. So the next time you look at an IKEA brochure, it ain't real. It's actually digitally rendered and recreated. Here's another customer here. A Frame is essentially the same type of solution for high-end visualization users, but except the fact that Frame actually does this in Azure and does it through a browser. So this is not using RDP. This is not using any other protocol. This is their own IP, where Frame is actually providing high-end visualization capability from within a browser, which is pretty incredible. They've actually launched a website as part of their page where customers can come in and try Azure directly within their website for free as well. So I'd recommend to go check that out as well. Visio 3D is one of the reasons I've put these guys in here, is because this is a AR and VR use case. So essentially they're using the power of the M60 GPU to stream content directly to the HoloLens, so it doesn't have to be rendered in the HoloLens and waste its battery, essentially. So it's actually they're actually rendering the stuff in the cloud and streaming it directly to the HoloLens so that people can interact with it. Now the cool thing here is that you can run up to 32 streams of 1080p directly into a HoloLens, and then you can run up to 8 streams of 4K video directly into a HoloLens from a single M60 GPU, which is pretty incredible. Bentley Systems is also another customer that is providing their 3D meshing program called Context Capture on Azure. So this is just one of the few many engineering firms that have switched to Azure for GPUs as well. Teradici is another partner. It's a remoting partner, so if you have things like desktop VDI type solutions, high-end workstations, Teradici is a great partner. They're actually offering 60-day free trial for Azure users today using N-Series, so I would highly recommend you go check that out as well. And then finally, we also have Citrix. So Citrix will be supporting XenApp and Zen Desktop on N-Series. They announced it at Ignite last year, and you'll be able to essentially run your Citrix VDI infrastructure on top of N-Series as well if you like. It should just work. So that's a wrap. And if there's any demos that you like and see, please let me know, and we will hopefully get those set up for you or point you in the right direction.